Hey guys, Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines. And tonight, this is applications of linear equations. Now you can call this an Algebra 1, Algebra 2, Calculus, it doesn't matter. It's just about how you take a problem, read the words, pull out an equation, and then solve it. Okay, so it does lend itself more towards the Algebra 1, 2 concept. So let's get after it here. Okay, number one. Now, by the way, this would be the way it is on the job. You're reading a report, somebody gives you some analysis or synopsis of some test data, and you're trying to pull from that an equation and solve for something. So let's read one of these. The sum of twice a number x and 7 is 21. The sum, okay, we know we're adding something. We have twice a number x, so we have 2x, 2 times x. The sum of twice a number x and 7 is 21. There's my equation, okay? So I'm going to subtract 7 from both sides. That equals 21 minus 7. These 7's cancel. So 2x equals 21 minus 7, which is 14. Divide both sides by 2. 2 over 2 is 1. 1 times x is x, so x equals 7. Okay? All right, and 2 times 7 is 14. 14 plus 7 is, in fact, 21. Okay, so that worked out okay. Hey, one down. And that really becomes the challenge on the job. It's all words. Now, I'm dyslexic, so that made my challenge even greater. Okay, I used to tell people if I could read, I could have amounted to something. And they said, well, you've got a PhD. I said, yeah. Fortunately, we worked with a lot of letters, a lot of numbers and the Greek alphabet. Okay. Number 2 here. 3 times a number x minus 8 is 43. 3 times a number x minus 8. 3 times a number x minus 8 equals 43. Okay, so 3x minus 8 plus 8 is 43 plus 8. So that's 51. So 8 minus 8. So 3x equals 51. Divide both sides by 3. X equals, what is that, 17. Okay, so 3 times 17 is 51 minus 8 is 43. All right, 2 down. Let me get my big eraser here. I need to throw my other one away and go get a new one. It's all grungy, to say the least. Okay, that's 2 down. Number 3, the sum of 4 times a number x and 17. The sum of 4 times a number x and 17. 4 times a number x and 17. The sum of 4x plus 17 is the same as 7 less 6 times the same number. 7 less 6 times, so 6 times minus 7. 4 times a number and 17, that's a 17, equals 6 times the same number less 7. All right, so let me take, since 6x is larger than 4x, I'm going to subtract 4x from this side. 4x minus 4x plus that's 17 equals 6x minus 4x minus 7. So that equals 2x, 4x, 6x minus 4x is 2x minus the 7. These cancel, so now I have 17 equals 2x minus 7. Okay, I'm going to add 7 to both sides. Okay, what does that give me? 24 equals 2x. Divide both sides by 2, so x equals 12. Well, let's see. 4 times 12, I put a 12 everywhere there's an X. So 4 times 12, 12, 24, 36, 48, 48 and 17, that's 15, 5, 65 on this side. 6 times 12, 12, 24, 36, 48, 60, 72. So 72 minus 7, hey, 65. So those are equal, so X does in fact equal 12. Okay. All right, 3 down. The challenge on the job so many times is how to read what's happening and be able to equate that. Put it into some equation so you can get an answer. And then sometimes the challenge is convincing other people that that's correct. Okay, that becomes maybe a larger challenge than getting the equation. Okay, 7 minus 5 times the number. 7 minus 5 times the number. 5 times the number, 7 less. Okay, is equal to 4 times the number and 25. The sum of 4 times the number, 4 times the number plus 25. All right, 7 minus 5 times the number is equal to the sum of, so we know we're adding here, 4 times the number and 25. Okay. All right, since 4x is smaller than 5x, I'm going to just subtract 4x from both sides. 5x minus 7 minus 4x equals 4x plus 25 minus 4x. So the 4x is canceled, so that equals 25. 5x minus 4x is x, so I have x minus 7 equals 25. So let me add 7 so I can get rid of that 7. Add 7 to both sides. So that goes away. So x equals 25 plus 7, which is 32. Now let's see if that's right. 5 times, so we've got a 32 everywhere there's an x. So 5 times 32, 5 times 2 is 10. Carry the 1, 15, 16. 16 minus 7 gives me 153. Okay. 4 times 32 times 4 is 8, 12, 128 plus 25. 13, 4, 1, 153. So x equal 32 is correct. All right. Now this next one is a little bit unique as far as just general math subject goes, but it's as much the real world as any problem up here. Okay, in all the other ones we had some number x. I mean, it could have been C, Q, O, whatever. But so many times you'll have to come up with the name of your own variable. You'll just have to figure out, well, what is the variable? How do I do this? Okay, Bob's age is 15 times more than 4 times Joe's age. Bob's age is 15 times, or 15 more, so you're adding something, than 4 times Joe's age. Well, why don't we just let J equal Joe's age, and B equal Bob's age. Okay, so it says that Bob, his age, so B, Bob, is 15 more than 4 times Joe's age. So 4 times Joe's age plus 15 equals Bob's age. And it says the sum of their ages is 45. The sum of their ages is 45. So it says Bob plus Joe's, their age, remember that's their age, equals 45. Well, you can see that if I were to just say solve this for Bob, for example, let me subtract a J from both sides. We're subtracting Joe. So Joe minus Joe is 0. Bob equals 45 minus Joe. Now I can take that and plug it right back in here, right? I can substitute now for Bob. Okay, let's see where we're going to do that. All right, Bob equals 45 minus J. So 45 minus J, I'm just going to substitute for Bob, equals 4J plus 15. Well, let me add J to both sides, since this 4J here and 1J there. So 45 minus J minus Joe plus Joe equals 4 Joe plus 15 plus Joe. Lots of Joes here. It's one of my best friends in China, by the way. All right, minus Joe plus Joe, these cancel, left us with 45 equals 4 Joe plus Joe, that's 5 Joe, plus 15. Now we've got to subtract 15 from both sides. 45 minus 15 is 30, and that equals 5 Joe. Can you still see that? We're getting right down to the bottom here. All right, so 30 equals 5 Joe. Divide both sides by 5. 5 over 5. Joe equals 6. 30 divided by 5. Okay, so Joe equals 6. So let's go back, plug in a 6. 4 times 6 is 24. 24 plus 15, 9, 39. So Bob is 39, Joe is 6. So Bob is 39 and Joe is 6. 39 plus 6 is in fact 45. So Joe equals 6 is the solution, and Bob equals 39. So we've solved for both their ages by reading the problem, developing our own set of variables, correlating those variables one to the other by what was given, and then said, well, Bob, his age, we solved for that, and then substituted that back in. So you had two variables, two equations, two unknowns, two equations, and that allows you to solve for both variables. Okay, this was application of linear equations. Hopefully you enjoyed it. And now why are we doing this? It's because we're crazy. No, we're trying to create a better tomorrow and do that through math. Okay? Study, study, study. I always say that. Practice your problems. Okay? All right, that's all for now, and we'll talk to you next time. Thanks.